In this video, I'm going to discuss about EM waves. So let's start the video. What is EM wave? Definition: electromagnetic waves are waves which can travel through the vacuum of outer space. EM waves are formed when an electric field couples with a magnetic field. And there is another definition of EM wave is the magnetic and electric field of an EM wave are perpendicular to each other and to direction of wave. EM wave. If you have ever tuned in, listened to a radio or a spoken headphone, turned on a light, hand on X-ray taken, felt the warmth of sun on your skin, you have experienced EM wave. Production of EM wave. When an electric charge vibrates, the electric field around it changes, creating a changing magnetic field. How do moving charges create magnetic field? Any moving electric charge is surrounded by an electric field and a magnetic field. This is picture in which this picture showing a moving charge. How to move a charge? An EM wave travel in all direction. The figure only show a wave traveling in one direction. Blue part showing magnetic field and yellow part showing electric field. These two fields are perpendicular to each other and the separation between two crust or trough is lambda and it is called wavelength. Properties of EM wave. All the EM wave are transverse. They do not require any medium to travel through. They travel the speed 3 into 10 to the power 8 minus 8 in vacuum. They can all be reflected and refracted. They can all be emitted and absorbed by matter. According to transverse nature, all particles are moving in the direction of motion. So it is called transverse nature. Electrospectrum. Frequency is called electromagnetic spectrum. Different parts interact with matter in different way. As wavelength decreases and frequency increases, and vice versa. Those spectrum which can easily seen by naked eye is called visible spectrum, and the ones human can see are called visible light and small part of whole spectrum. Chart of wavelength and frequency. Frequency is increasing order from radio to gamma rays. Gamma rays having high frequency and radio wave having low frequency. Those one which having high frequency having short wavelength and those having low frequency having long wavelength. So radio wave having long wavelength and gamma ray having short wavelength. This is the electromagnetic spectrum shown in the hertz, kilohertz, megahertz and gigahertz. And this is the increasing order of radiation frequency. So computer having 60 to 100 hertz frequency, microwave having 3 to 30 gigahertz frequency and cell phones having 1.9 to 2.9 gigahertz. This is the table for frequency, wavelength and energy. The radio waving having low frequency and high wavelength, and gamma rays having high frequency and low wavelength. This is the increasing order of frequency. Radio wave having low frequency and wavelength greater than 0.3 and gamma ray having greater than 5 into 10 to the power 19 frequency and wavelength is less than 6 into 10 to the power minus 12. Radio waves. Radio wave having the longest wavelength of all the EM wave. Low frequency. Radio waves are Radio waves are often used to transmit data and have been used for all sorts of applications including radio, satellite, radar and computer networks. Radio waves are used in medicine. It is used to produce images of soft tissue, fluid, fat and bone. For example, MRI and RFA. Diagnose many problems, for example, help identify tumors. Radio frequency ablation used to heat, destroy the cancer cells. Microwave. Microwave are radio waves with wavelength less than 30 cm and high frequency and shorter wavelength. Cell phones and satellite use microwave between 1 cm to 20 cm for communication. Uses of microwave. Microwave are useful in communication because they can penetrate clouds, smoke and light rain. Microwave also in radar help to predict the weather. Infrared waves. Infrared waves are sometimes classified as near infrared or far infrared. Between microwaves and visible light are infrared waves. It can be detected by heat and used in heat lamp. Higher energy than microwave and lower than the visible light. Used daily in remote control and read CD-ROM. Infrared imaging in medicine. It can be used for oncology, vascular disorder, respiratory disorder, skeletal, neuromuscular diseases, surgery, tissue viabilities. Visible light. This is a range wavelength from 390 to 700 nanometer, which corresponding to frequency 430 to 790 THz. The portion of electromagnetic spectrum that human eye can detect, that is called visible spectrum. Visible light used in medicines. Visible light is also used in scanning laser, ophthalmoscope and endoscopy, keyhole surgery. UV wave. Ultraviolet waves have the next shortest wavelength after the visible light. EM wave with wavelength from about 400 billionth to 10 billionth of a meter. Used in tanning beds and sterilizing equipment. UV rays used in medicine have enough energy to enter skin cells, longer wavelength, shorter wavelength. Both can cause skin cancer. X-rays, high wave energy used in medicine, industry, transportation. Too much exposure can damage the living tissue or even cause cancer. X-ray used in medicines. X-ray play an important role in dentistry and orthopedic investigation. They can penetrate soft tissue like skin and muscles. I used to take X-ray picture of bones in medicine. Gamma rays. Gamma rays are the highest energy electromagnetic waves. They actually come from radioactive elements or stars. Inspection tool in industry. Gamma rays used in medicines. Positron emission tomography (PET) is a nuclear medical imaging tool which used for gamma rays. Example: neurological diseases such as Alzheimer's and multiple sclerosis. Effectiveness of treatment. Heart condition. Gamma knife use beams of highly focused gamma rays to treat tumors or other abnormalities in the brain. Gamma rays can check how far a cancer has spread and how well treatment is working. Thank you. If you are new to my channel, please subscribe my channel and don't forget to press the bell icon. Thank you.